Hi, my name is Paige Mayfield, and today I'll be presenting Lab 1 charged take. So the goal of this experiment was to investigate the properties of electric charge and how two charged objects interact. We used clear tape to create charged pieces, then measured their forces of interaction. From this, we estimated the amount of charge on tape, calculated the number of displaced electrons, and compared two computational models, the point charge model and the line charge model. So for this, we connect several fundamental physics ideas, including Newton's law. So they describe how the forces are acting on the tape, Coulomb's law, about how the electric force depends on the amount of charge and the distance between the charges, electric field, a charged object produces a field that exerts force on another charge, and the force of charge that links the field to the observable motion of the tape. And our main results were that the clear tape carry same positively charged and repel each other. They measured on the charge was this. We also observed differences between the point charge model and the line charge model. So for this, we have some assumptions that tape can be treated as a point charge, and the charge is considered to be from the center of the tape. Each U tape has the same charge evenly distributed throughout, and air resistance is negligible in our calculations. So in our procedure, we created these two U-shaped tapes and ripped it off the table, and we test the polarity by approaching the tape with a known negative object, and we determined that there is excess charge on the U tape by adjusting distance until one tape floated above the other. We balance electric force from the lower tape with gravitational force on the suspended tape, and the top tape is considered to be at equilibrium because the electric force can be determined by calculating gravitational force. And then the electric field was later computed algebraically, and for this, our system was the floating U tape. The surroundings was Earth and gravity, lower charged tape, and air. This is a photo of our experiment. So in this, we observed that the U tape was attracted to a negatively charged pin, confirming it was positively charged. The tape was also attracted to a hand, showing charge leakage when touched. Two U shapes repelled each other, demonstrating that like charges repel, and the floating tape reached equilibrium when the upward electric force was equal to the downward gravitational force. So here are our calculations. So we have our length of tape, the width of our tape, and the distance between the two floating tapes, and the mass. And then we calculated gravitational force to be this, and our electric force. And then E was equal to 1.75 e to the 5, and our number of electrons, number of atoms, and electron per atom. Here is our code for this model, and then this one. Okay, so our experimental questions. If protons were negative and electrons were positive, the signs would reverse, but the magnitude of the forces would be the same. And then we want to handle the tape as little as possible because touching them lets charge leak onto your hands, and it reduces the repulsion and weakens the results of the experiment. And this could have been a source of error in our experiment. So what does this all mean? This means that everyday materials can hold measurable electric charges, and it highlights why choosing the right physical model matters. So in conclusion, like charges repel and opposite charges attract. The floating tape demonstrates that electric and gravitational forces can balance, and we estimated the charge to be about 1.75 e to the 5. This corresponds approximately to 7.06 e to the 10 displaced electrons, or 1.77 e electrons per atom. A line charge model would likely give a more accurate result because it's distribute charge along the tape instead of assuming a point, even though the other model is easier to compute. It doesn't give you as accurate of an answer. So this experiment was connecting our hands-on observations to fundamental physics concepts and gave us practice modeling real systems and simplified and more accurate approaches.